Alright, so our third example, we don't have to do a proof, but we're going to find the measure of one of the angles in this figure. We're given some information. We know that ray KJ is perpendicular to ray KM. So here's KJ, here's KM, and we already have that perpendicular right angle marked. And then here's the part that we need to make sure we understand. It says angle JKO is 5 times as large as angle MKO. So here's JKO, it's 5 times as large as MKO. And we have to find the measure of angle JKO. Alright, so here's what we can do. We're going to go ahead and label angle MKO, so the smaller one right here. We're just going to say that that has a measure of x. We don't know what it is, but that is x. Now, if JKO is 5 times as large as this, how do you think we can label that larger angle? We can go ahead and say it's 5 times x, or 5x. Now we've got these two smaller angles right here, and these two smaller angles will add up to this big angle. So we know that angle JKO plus angle OKM will equal that big angle JKM. And that's basically what we're going to fill in. And I think I wrote that the wrong way, JKM. Alright, so JKO is 5x plus OKM is x, and it's going to equal that bigger angle, which is 90. So then we're just solving an equation, just like algebra. So if I have 5x plus x is 6x equals 90, divide both sides by 6, and x equals 15. Now in problems like this, don't get too far ahead of yourself. You think you're done because we solved for x. You know, in algebra we were done at this point. But you want to make sure you go back and you look at what they were actually asking. They want you to find the measure of angle JKO. So JKO, so the measure of angle JKO is equal to 5x. And now that we know what x is, we can go ahead and plug that in. So we're just going to say 5 times 15, which is 75 degrees. So the measure of angle JKO equals 75 degrees. And that answers the question that we were asked.